Hello, welcome to the demo of detecting and investigating the tactics of state-sponsored espionage groups and cyber criminals. It's no secret that state-sponsored attackers have been exploiting victims around the world and across all industries. These threats go undetected because most companies can't afford to analyze the data to detect the threats, or their tools don't have the capabilities required. Take Powershell Empire as an example. Its use has been attributed to millions of dollars in damages to victim organizations. Powershell Empire is a pure PowerShell post-exploitation agent. It has been used to exfiltrate data and maintain persistence. Detecting Powershell Empire requires analyzing the activity on every single host in your organization. Traditional security analytics tools struggle to detect this type of threat for a few reasons. The data is complex and increasingly requires combining massive data from your cloud providers with your traditional data. Analysts are flooded with too many alerts without the right context, relationships, or prioritization. And too often, the pricing model and infrastructure requirements make the cost too steep, so organizations are forced to say no to the data that they need. But it doesn't have to be this way. The Databricks Unified Analytics Enterprise is an enterprise cloud platform rooted in open source. Databricks allows you to collect any data from anywhere and is an inexpensive way to detect and investigating threats using massive amounts of data. In this demo, we'll show you how you can detect and investigate Powershell Empire. We'll start by looking at a morning dashboard of alerts. Next, we'll see how a security analyst would investigate the alerts with external tools and a Databricks notebook. Then we'll pivot and show you how we can run detections and how we make content creation better. All of this will be taking advantages of Databricks' unique cost model that allows us to analyze all of the data using low-cost object storage in the cloud with an open source data format. Let's go ahead and jump into the demo. So here we're looking at Redash, a visualization tool where we can visualize all the data and alerts stored in Databricks. Here's we have some visualizations that's showing our daily alerts compared to their baselines. We can also see trends over time. And we can also even see individual alerts fired off within our environment. Here's one of the recent ones that's fired off for this machine venus.froth.ly. And we can see here by diving into the alert that we have 6 different detections for things like encoded PowerShell, first-time active user, and other suspicious activity. If I'm a SOC analyst, I can click into this link here, and I can get context around this event and see what's happened. I can sort based on any of these parameters, time, or risk score to see the most threatening detections. And because Databricks stores all the data, I can drill down even into the raw event. For this encoded PowerShell alert, we can see that PowerShell, it's being fired off with this large encoded string. And we see PowerShell being launched by WMI. Definitely a sign of lateral movement and malicious activity. So if I'm a SOC analyst, the first thing I'd want to do is grab this process GUID and find out a little bit more. So let's jump into a Databricks notebook that we've built to investigate processes. Here you can see an open source force-directed visualization that shows us the processes and their relationships. It makes it easy for me to see that, for example, that this PowerShell exe creates a scheduled task that's being run daily and is used to maintain persistence. But the really powerful element here is that because Databricks is a true platform designed to let you use the tools that make you powerful, it took me just a few minutes to add an open source Python viz to this notebook, allowing me to empower my analysts with the tools they need to be effective. Based on the myriad of processes that this PowerShell exe is spawning, it's clearly that we have a lot of trouble. And if we were a SOC analyst, we'd want to continue our investigation to see how this was installed with WMI in the first place. Let's pivot, however, and see how we can build detections with Databricks. With Databricks, building a detection for encoded PowerShell is straightforward. You can have descriptions and filters or advanced AI or machine learning triggering alerts. Databricks notebooks are flexible and you can use whatever language you're comfortable with to build detections. I'm using Python in this notebook, but you can also use SQL, R, and Scala. And because Databricks is a content creation platform, it allows us to track the health of our detections with something called ML Flow. Using MLflow, we can log different tags, such as whether an alert is in development or in production. We can also track parameters after alerts, such as the query and filters. Finally, we can track the metrics, such as the number of alerts fired for our detection. After we've integrated MLflow into our detections, we can track our detections using MLflow experiments that allow us to track the health of our alerts over time. Here we can see all of the alerts firing in our system, the query triggering the alert, as well as the number of alerts fired. We've just shown you how you can detect malicious PowerShell and trigger an investigative process with Databricks, as well as report your findings in a dashboard with Redash. Of course, the range of capabilities Databricks offers for security is tremendous, and we would love to sit down with you and show you the full version of the demo. But there's also things you can do here at Spark AI Summit. I hope you can attend our fireside chat, Transforming Security Analytics for the Cloud Age with Kelsey Tejan from Sandia National Labs. Or attend the session with Apple, Scaling Security Threat Detection with Apache Spark and Databricks by Josh Gilner. Thank you for your time.